Hi, my name is Samuel George, and this is part 4 of assignment 5 for Comp533. In this part, we're going to show the code used to generate the 500 commands for each simulation, as well as the timing results of using Gypsy's implementation, as well as the 2 serialization schemes that we've created. Okay, so if we look at the code in client 1, whenever I type in performance test, we get a print that runs performance tester.gypsy.performance experiments, which is here. And then our performance experiments go through each of the modes and runs all the commands. For the textual, it gets so backed up I have breakpoints here to let it catch up before we start the next simulation, but we'll go over that when we get there. So to begin, let's just go ahead and start a server and test the default serializer. Okay, now we're going to move this out so we can see a couple of them, and we're going to type in client 1 performance test. Okay, local was the one underneath. Non-atomic is going to be these guys, and atomic is going to be these guys. Okay, as we can see in these modes, these have to catch up eventually, but these are our timings. So we have 1056, 5043, and 881. This is in milliseconds. So I went ahead and recorded some times, close enough. So this is for the default. 5000. For the 963, we're going to say 818. Okay. And that is for those. Okay. Next, we're going to do the same setup, except for we're going to use the custom one, which is going to call our serializing factory. Let's go ahead and start with binary. Okay. And we're going to test using the server custom client 1, which again uses the same factory. Client 2. And client 3. We're going to spread these out. And we're going to do client 1, just like we did last time. Call performance test. Okay, so now we're in non-atomic mode. Okay, and we've gone to atomic mode. Okay. And we see the AWT threads catching up. All right, so in this mode, we got 1042. This one took a little longer. And 133. Okay. All right, and we're going to do the same thing using textual. Okay. And for this one, I'm actually going to run the client that's going to switch the modes in debug mode so we can stop one at a time, because we'll see the movement. The deserializer is much slower for textual than it is for the byte case, because you have to make a new string out of each one and it's much more involved. So we are going to just pause and let the demo catch up during those 3 modes. So that we don't get too much of a weird error. Honestly, it shouldn't affect. So we're going to call the same performance test. As I said, we're going to test local first, switch to local mode, test everyone. That's what it takes for local. We're going to send non-atomic mode for everyone. Test non-atomic. See our simulation's moving over there. And as we can see, it's going to take much longer. It is much slower. So something on 6691, and that's that part. And then when we test atomic, again, testing atomic mode. Okay, So we get our times here. And we can still see the graphics were still moving back there to finish up. So the speed is 0.7. So it appears based on timing. I've done it a couple times here, and each time, sometimes it's usually a good deal slower, at least than a default, and sometimes even slower. But just looking at the timings here, we can see that definitely my two serialization schemes are relatively slower. However, a lot of the speed that we saw, particularly when we saw how long it took the graphics to catch up, was mainly due to the deserialization taking much longer. The serialization part, which is basically what this is timing because none of the commands are blocking once they send. So they're calling the echo string, that's not blocking. And so what's actually taking a long time is deserializing the commands that come back the other direction. So I'd imagine that I have a multi-core system here, so it actually does a pretty good job. But you can imagine how if these two were in the same thread, for example, it would be very, very, very slow for the textual as compared to both the binary and the default. And we can see that the binary is actually not too much worse, and based on the commands over here, was not too bad. So indeed, the textual, it seems like, in terms of byte size as well as serialization, it is not too much worse. However, when it comes to deserialization, it is much slower. So that covers our code for 500 commands and showed the timing results for both schemes. And this completes assignment 5.